Okay, this is an example of a normal distribution question that has a little bit of binomial probability in it as well. It's actually example 3 on page 42 of your textbook, so you can look it up in there if you want to. I'm not quite sure how neat my writing is, sorry. So we've got an IQ test applied to a population of adults. The scores are normally distributed. So this is true. So IQ tests are results are scaled so that the mean is 100, standard deviation is 15, and adults scoring more than 140 are classified as being genius. And we want to find, first of all, the probability an adult randomly chosen is classified as a genius. So you should be fine with this from last lesson, but I'm going to, sorry, I don't know if you can see my screen slightly better today, but we go to option 7, so you kind of scroll around, or just do menu 7. And then it's normal cumulative, so don't worry about the PD normal, just leave that. So normal cumulative. The lower bound, so you want the probability that x is bigger than 140, that's what we're looking for. So the lower bound is 140, upper bound 5 times standard deviation above 140, above the mean is absolutely fine, but just chuck in a big number, so 2000 would be fine. The mean is 100 and the standard deviation is 10, so I need to put in 10, it's 15 for the standard deviation. The mean is 100, and you end up with 0.00383 to 3 sig fig. So 0.383% of the population is classified as being genius. Right, now on to the next bit. We've got 20 adults take the test, and we want to find the probability that 2 or more are classified as genius. So we now have a fixed sample of size n. We have 2 possible outcomes. You're either classified as genius or you're not. And so we're in a binomial distribution. So if you let y be number of adults who are genius, and then y is binomially distributed, n is 20, and the probability of success is 0.00383. And within that binomial distribution, we want to find the probability that 2 or more are classified as being genius. So the probability y is greater than or equal to 2 is 1 minus the probability y being less than or equal to 1, so that your calculator, when it does cumulative probabilities in the binomial distribution, it will only do less than or equal to probabilities. So you need to convert these greater than or equal to ones, like so. Any problems with that, you need to tell me. So back to the calculator, menu 7 again. This time I want binomial cumulative. So you need to scroll down, press option 1. Just want a single value, so 2. And then x is 1, so that'll give you the probability x less than or equal to 1. N is 20. And I probably should have stored this actually from the last go, but I'll go to 3 sig fig on this one. So 0.00383. So we're expecting quite a low, very high probability from here, sorry, because when we do 1 minus it comes out low. So 1 minus 0.9 9, 7, 3, 4. And then you can store x. So I can store that to x. Menu 1, 1 minus x. And that comes out as being 0.0026623 sig fig. You can write it in standard form if you want to. You probably use standard form more than me if you do science, but so decimal or standard form is fine. And then I could have here, when I had that original probability, so my lower is 140, upper something high, standard deviation is 15, mean is 100. I could at that stage there have stored that to x, and then when you go into your binomial probability, the cumulative one, you can then actually just put that in as your probability, and then that will just make sure you don't get any rounding errors. So if I do x there, then yeah, that will avoid a rounding error. So do get into the habit of doing that sort of thing. Yeah, and you can get a few of those now. Thank you.